Hi, here we are at the Liquid Lounge on Cordon Street in Winnipeg, Manitoba for the second part of Cosmos versus Canvas. Okay, this is the technical part. It's going to be in a couple of different videotapes. We're going to start with the black and white stretching of your data. Then we're going to make color images and do a critique. So thanks, Mark. This is Mark, the manager.
Hey, Adam.
Thank you very much at the Liquid Lounge. L'chaim. Okay, the most important part, remember, about making images is to use visual grammar to make them readable and appealing to the public. And you'll notice that I chose green to match my pink cuffs. You see the pink cuffs? Green olives going with my pink cuffs to make a very harmonious image. Visualization stages. This is the overview of that. First thing that we do is we stretch our black and white images. In this image you can see we don't see much in our data at all. In this image we get a lot of information out of our data. The next stage is to assign colors to each of our data sets. In the case that I'm showing here, I guess we have 4 data sets. So ultraviolet, colored magenta, the blue filter, blue, the green filter, the visual filter, a yellowish green, because that's actually at the center of the wavelength region. And we have an infrared colored orangish red. Stage 3, we combine those down here into an image. And it's still not perfect. We have to do some cosmetic work, removing chip scenes, and adjust the colors, rotate and crop until we get our final image. Okay, so those are the stages we're going to go through. First, we're going to start right now with the black and white imaging. So to make your black and white stretches, I'm going to assume that at this particular moment, I'm talking to professional astronomers, and you're working on Linux boxes. So to do your stretch, you can use whatever astronomy package you like. It's the most easy way to fine-tune your black and white stretch. So you could use DS9 to do your black and white stretch. What I like is to use what's on the screen here. It's a radio display, but it works perfectly good for optical images. It's called KViz, and it's in the Karma suite, and it's free. And I'm going to show you how to use that, but you're welcome to use DS9. If you're not a professional astronomer and you're going to be using Photoshop to make your images, get a plugin called FITS Liberator, and that will allow you to stretch FITS data. Most astronomy data is in FITS format. That's professional astronomy data. And if you're an amateur, even you can make images using Hubble Space Telescope data, which is a FITS format if you have FITS Liberator.
Jen, can you tell us what the stretching is?
Stretching means that you're going to assign levels of gray to certain data values. So you can imagine that if you had something that had data values ranging from 1 to 100, you could make white at 100 and black at 1, and then all the levels in between are gray. But our data has different values than that. So we might want to do, we might have thousands of data values and only 256 levels. So what we want to do is compress, in a way, the data values into those gray levels. So that's called a stretch. So you can imagine if you have something that's thousands of data values, that you would use a logarithmic stretch, and then you're just dealing with the log power when you're doing the stretch.
So when you say stretch, you actually mean compress?
It could be either, and it's just historically called a stretch.
Okay. Say for example, like you make an image which is not stretched, and then like you have an image which is stretched. Like, is there much difference between these 2 images?
Excellent question. Yes, there's a big difference. When you do, for example, a logarithmic stretch, you're going to show off the faint values at the same time that you show off the bright values. If you do a linear stretch, you won't be able to accommodate the faint emission if you're accommodating the bright emission, and vice versa. If you bring up the faint emission, you'll saturate the bright emission. So if you're going to be doing a nebula, it's often a good idea to do a square root stretch. If you're going to be doing galaxies, it's really good to do a logarithmic stretch. But the best thing to do is experiment and see which stretch you like. And what I'm going to show you is kind of an arbitrary stretch on top of doing those standard stretches. Okay, so then that allows you to bring up a lot of information. Okay, let's go back to Karma and do our stretches. I've opened it up here and I have some radio data here just to demonstrate you can do this for radio data. And the first thing you do is you decide on what intensity you'd like to do. So you go to intensity, and you come down to your policy. I'm going to select a log to show my data. That. And I'm going to also zoom in on something that I'm particularly interested in this data. Now, for the stretch, you can actually pop up a histogram. So you come out of the browser from here and down to the histogram over here and select the data values that you want to display. The goal for creating stretches is you don't want to have many objects in your image white and you don't want to have a lot of black. You're going to be combining images together, and when you add 256 color levels together, they're going to add up to white. So you want to have grays in your images so that when you add them together, those values won't add up to 256, and instead you'll have color instead of white. Okay, so I'm going to show you one of the things that we can do. As we talked about the stretch, for this I have determined if I use intensity policy that my best kind of stretch here is in a log stretch. Linear looks like that, you don't see much, and a log stretch gives you a lot more information. Okay, so I'm picking the log stretch. Then the next thing I want to do is, well, some of the data values aren't very useful to me. They're not giving me too much information. I'm going to test these out. To do it, I want to pick my faint data values first. And in Karma, the easiest way to do this is just look at them in this histogram. You can see the noise is on the left-hand side in a peak. And I don't need anything too much below the noise, but a little bit below the noise I'm going to retain. Okay? Then I'm going to zoom out on the histogram and pick my upper level like this until I get a nice series of grays. I'm also going to go use this function here called pseudo color. And my favorite grayscale here is grayscale 3, which is non-linear. And then I'm going to move this till I get most of the image looking gray, not black and white, gray, and show up features that I like. One thing that I wanted to show you before I leave the black and whites, when you're dealing with radio data, infrared data, CO data, this is also pretty important. Besides making sure you don't have total blacks, and besides making sure you don't have total whites where you can avoid it, there's going to be something very important in terms of artifacts in your data. So I'm going to zoom in here, and we're going to see the noise in here. Now, you see all this dimpling here? Can you see all the dimpling in the image? Okay, so that's due to the longest baseline. That's what the noise looks like. It produces these dimples. The public don't understand these dimples. They'll go, you've got a crappy camera. So we're going to have to take care of that. We're going to have to do something to get rid of those dimples. We want to not, in our images, post questions about artifacts about image making or data collection. We want to only have them asking questions about the science and the astronomical objects.